snapshot from the email that went out. What's the date? So this email went out yesterday. So my view, notice it's my view of the internet, your view will be different. The internet looks completely different every place we look. So just short of 580,000 prefixes, that's the V4 table. Yes, I'm looking at the V4 table. The V6 table, if you're interested, is about 25,500 prefixes. You must take a look at the V6 table as well, because the V6 table is not perfect, and guess what? The same badness is happening. Anyway, 580,000 prefixes. Now, one thing that I do in this report is take the BGP table and aggregate it by origin AS. In other words, I look at what perfection could be. If everybody aggregated and there was no traffic engineering needed at all, how big would it be? 214,000 prefixes. So you can actually throw away 385,000 prefixes in the BGP table and nothing will break. Nothing will change. So these 385,000 prefixes you're carrying around are basically extra luggage. You know, when you've got too much carry on the plate, it's just extra. Not needed. You can get rid of it. So yes, the BGP table is 2.71 times bigger than it needs to be. And that's fine, you're probably happy about it. If you carry the full routes in your router, you think this is probably great. Your supply of your routers is delighted because you're buying gigabytes of memory, whereas previously you probably wouldn't need to buy gigabytes. So they're happy they can sell really expensive memory to you. Now if we look through it, 52,500 autonomous systems out there, about 11 prefixes per AS out there. Seems pretty reasonable. If I wander through all this, oh yeah, some people still believe that 32-bit AS numbers don't work. Got news for them. So the 12,000 have been handed out by the registries, and about 9,500 actually use out of the internet. So if they don't work, how do these 9,500 actually function? What other bits are interested? Oh, the AS path prepends. So AS 40,285, whoever you are, seems to think that the 34 times prepend is really useful. So the BGP folks amongst you will realize that that's actually quite stupid. The biggest prepend you need is probably 4 or 5 to do traffic engineering. 34 is just stupid. There's no other description for it. So there's a summary. I'm not going to go through everything because I've only got less than a half hour for this presentation, because the more interesting things to look at. We look at the APNIC region, 147,000, 148,000 prefixes caused by autonomous systems based in the Asia-Pacific region. If those ASs did a bit of aggregation, we could bring it down to 40,000. So yeah, there's just over 100,000 prefixes of junk in the Asia-Pacific region BGP table. So 3.6 times bigger than it needs to be. 88% of the APNIC address space is amounts, so 12% of it is hiding somewhere. What else is interesting? Yeah, I think we'll just move onwards. So let's look at, this is the number of prefixes per AS out on the internet. So these are the top 20 contributors to the BGP table that I'm seeing, in my view. So China Education and Research Network needs to announce 5,599 prefixes. Well, that's quite a lot. China's a big country, they probably have a big network. But one thing I do is, look at that max ag column. That's if they actually aggregated. So if they did their aggregation properly, they could reduce their announcements down to 76. So announcing 5,523 of junk, not needed. The long-term number one was Telemex in Colombia. So this is actually a Mexican provider that's big ISP in Colombia. Announcing 3,415, could be down to 143. The first North American is Cox. Our dear friends in Australia, TPG, have always figured in the number 1, number 2, number 3 spot. Australia is not a big country, with 22 million people. Why we need 3,138 announcements in the BGP table, I have no idea. Korea Telecom, Telecom Indonesia, you run through the list. SaudiNet has been a recent appearance. I don't know why they've deaggregated the manual address blocks into 2,515 prefixes. So this is like the top 20 hall of shame. I guess marketing departments see this as the top 20 biggest ISPs in the planet, but they're wrong. In fact, you know what? Not long after I started working in the region, I came across a lot of providers whose marketing people actually use the cyber report as a means of saying how big they are. No, it's not how big or how good, it's how bad you are. So anyway, there we are. And if you see your cell phone here, you should be embarrassed. Just looking at the size of the BGP table, I'm always interested in tracking the /24s. So this time last year, actually from the presentation that was done in SANOG in Kandy in Sri Lanka last year, we had 282,000 /24s. That's now morphed up to 317,000 /24s. People love /24s. Most of you are too young to remember Class Cs. Why do you have all these /24s? It's kind of interesting. There's not much growth anywhere else. 23s are growing a little bit. Yes, we see some /32s out on the internet. What do our postflags? And what else is exciting? Number /8 is fairly steady, 9s and 10s and so forth. The 24s are showing a big growth. The 5 regional registries also publish the minimum allocations, the smallest address block they've ever handed out. This is looking at the prefixes that are smaller than anything the registry has ever handed out. Because some people say, oh, well, but the registry only gave me a /whatever. Well, you check all that, and Cox and Saudi, you know, all these people here that seem to think that, well, they've announced smaller pieces to the global internet than the registries even do. So, anything from the Asia Pacific region? Well, no, well, apart from Korea Telecom, which is kind of interesting, because they can make some minimum allocation as a /24 across the board. And they can make really has no address space left. So, minimum was a /24 across all address blocks, which is why they know they can make address holders up here. So, the BGP table is growing. That's what it looks like. So, those are the early years. I'm not very good with doing graphs, so that's really from 23rd of February 1999, and then each year since. So you see the early growth. So from 98 through to about 2001, that was the big internet boom when everybody was rushing to get onto the internet, where the .com crash, which was the yellow line. People said that was the end of the internet. Of course, it wasn't. I mean, it's just the venture capitalists weren't interested in it. And then about 2006, things started growing again. That's the green line. And then about 4 years ago, when V4 started running out, the BGP table started growing faster. So it's now actually growing faster than it has ever grown in any time with memory. The vendors are delighted because you can sell you lots of memory. Well, not like the service providers being delighted. The autonomous system number growth. You see a very similar trend there as well. That step was when APNIC actually upgraded the routers to support 32-bit AS numbers. Before then, it only looked like AS23456. So it was kind of tailing off. Then suddenly we could see the 32-bit AS numbers, and then on the growth happened. Other artifacts are real. Don't know what the cause is. Having 1,000 autonomous systems just disappearing, maybe it's something on the router that I was getting review from, no idea. What else? There you go. The yellow is the growth in the global table. The blue line is the aggregation that we see. So it's, if I aggregate it, so the actual growth of the tables, it's almost linear if everybody would aggregate, which I think would be reasonable, but we haven't looked at the other one, but it's probably not exponential, but it's certainly growing pretty quickly. And the red one is the unique prefixes. Now what's happening here is that network operators are taking, say they've got /19 and dividing it into component pieces. Like maybe, I was going to say maybe 220s, that's not likely, more like 421s or 822s. And then answer 822s, but not the covering aggregate. I don't know why anybody would even try and do that. That seems very strange. They obviously don't want any redundancy when any links fail, if they're doing traffic engineering, or just do they have no idea what they're doing. It's kind of interesting. And you're seeing that over, the red line overtake the blue one. A few years back, I never expected to see that. But for some reason, operators are taking the aggregates, no longer announcing the aggregate, and dividing the individual pieces, announcing the individual pieces out of that. It's very interesting. Looking at the other ones, like the 19s through to the 23s, the yellow line is the 21s, and we saw the 21s growing pretty quickly, and then tailing off. The sky blue is the 22s. So what's the maximum address space you can get from Ethernet, RAP NCC? 22. So you see the fairly rapid growth in the 22s being announced, and others are diminishing. /19s are a flat line now, which you would expect. /24s, onwards and upwards. What else? Address space announced. You notice in the top right there, it's tailed up. I don't know, is that real or just a temporary thing because it's over the time for the last couple of months? I really do think that the amount of B for address space that's been announced on the internet has peaked. So there is quite a lot of other B for address space still around, but I don't know if it will ever be flushed out. I guess buying B for address space on the market is still way too expensive. Compared to getting it from registries such as it is, or maybe people are deploying V6 more and more now. Don't know, it's kind of interesting. I'm going to watch that on the top right there over the next few months. It'll be kind of interesting this time next year to see where we're going with that. Yeah, sorry, I forgot about the transition. There we go. Announcements of autonomous systems. Okay, the light blue line is an artifact of my program. The actual thing that produces this graph can't measure 32-bit AS numbers, which is why that's tailed off. I need to fix this, and that's been on my to-do list for a long time. That's why it's tailed off. The actual growth in ASNs is onwards and upwards, but it's a straight line. Quite an interesting straight line. The number of autonomous systems that only provide transit, there are only 170 of them that don't originate any prefixes at all. They're transit only. There's a yellow one, and those that have originating prefixes as well as transiting other ASNs. There are not many autonomous systems that are providing transit. About, what's that, 6,000 out of the total of 52. So most autonomous systems on the internet are at the edge of it. Next one's fun. Maximum AS path length that I've seen on the internet. So what's gone wrong for 1, 2, 3, 4, 5, 6, 7, 8? 8 years ago, suddenly things started going really bizarre. So up to about 2007, nobody really announced really long AS paths. And then suddenly, from then on, you got some amazingly long AS paths. The longest continuous one in, what was it, AS 55644 announced 111 times pre-pen for about 2 months. Don't know why. AS 5404 announced 51 times pre-pen for almost a year. That one came up on the SANOG, North American Network Operator mailing list. And one of the people there actually asked the service provider in question, and they said, not me, nothing to do with us. But it's your AS number. Oh, no, that's not us. So that was very odd. So one thing, as I said, I was doing is I looked at the deaggregation. In the cyber report, of course, Jeff Houston took it over from Tony Bates, early 2000, and added a whole bunch of features to it, including the ability you could actually put in the AS number and it would tell you how to do your aggregation. And so it's actually pretty good at doing all that. So there's that there. I've been looking at it from the per registry basis. And one thing that I do is just look at this deaggregation factor following a suggestion from somebody from the community. How many times bigger is the BGP table from what it actually could be? And so here we are. This was just again yesterday. Globally, it's about 2.71. If you look at Europe, Middle East, and North America, the table is 3 times bigger than it really needs to be. And that's grown not very much over the last 50 years. But here, Asia Pacific region, Africa, Latin America, and Caribbean, we seem to have the need to do a huge amount of de-aggregation for, I don't understand why. People say, oh, but you know, the core of the internet's North America. No, it's not. Oh, well, but you know, the ISPs in Europe and the Middle East have been around a lot longer than Asia. No. Eastern Europe, Central Asia, Middle East, they haven't been there. A lot of new growing networks there, so that's not the reason. Asia Pacific, some of the oldest ISPs in the world are Japan, Australia, New Zealand, and so forth, so that can't be the reason either. Who knows? But you know, there we are, we track each one. And you can see the global growth versus what's happening in certainly Latin America. It's very erratic, Africa is very erratic. Asia Pacific, during the big boom, and you can see the effect of the dot-com crash as well. Somehow, we stopped de-aggregating in this part of the world in the dot-com crash. Why? Nobody else did. But we stopped de-aggregating. I don't understand why that happened. I've looked at the data, I've rerun it again, we stopped de-aggregating. So it dropped from like 2.7 back down to about 1.6. Right? And then notice at the end there, any ideas who caused that little step at the end? That's when CERNet de-aggregated. I don't know why they de-aggregated, I must actually ask them what happened there. But they caused the entire de-aggregation factor for the Asia Pacific region to jump over 3.5, the noticeable step. So we look at the potential savings for the Asia Pacific region. These are the highest savings possible. So, you know, CERNet isn't even the highest saving possible. The number one most polluting provider in the Asia Pacific region are TPG in Australia. Number two most polluting, Indonesia, Telecom Indonesia, Korea Telecom. AS9829, I'm sure, is sitting in this room, and I'm sure AS4755 is sitting in the room as well, as are AS9498, and so on. I don't know if 17488 are sitting in the room, or 24560. Check your routers, fix your BGP, please. You're wrecking the internet for the rest of us. That's really what it is. There's no reason. You cannot tell me that your traffic engineering because of 5,000 external links that need delicate load balancing over. But that's what it is. It's just pollution, laziness. What about Nepal? I thought I'd do this just for fun. So, Nepal Telecom. Hello, where are you? How's your BGP looking? Not good. Mercantile. And so, actually, this is most of the ASNs here. I don't have 32-bit AS numbers because I was rushing to do this this afternoon, just before a meeting. So, those of you with 32-bit AS numbers, you escaped. But there are about 10 of you. I don't know where you fit in the list. But, so, basically, the savings column is, if you aggregate it, that's how you would help the internet. Now, you probably think, well, this is tiny compared with the global 300 and whatever thousand that could be saved. But it's the same thing talking about, you know, the whole big discussions about global warming. Oh, well, we're not going to do anything until the US fixes itself. Well, everybody needs to fix itself. The internet is not somewhere else. We are part of the internet as soon as we connect to any other provider. It's our internet, not somebody else's internet. So we all need to do a little bit to help. Anyway, so there you go, a bit of interest. Some people say the size of the routing table doesn't matter. Oh yeah, I can get 16 gigs of RAM in my router now from my favorite vendor. Yeah, you know, some providers are carrying 1 million prefixes. Actually, some are carrying 16 million prefixes. It just works. Our vendors have come and saved us yet again. Why do we want to do that? You know, the vendors, of course, are quite happy to, well, I don't think they are happy, but you know, they're quite happy to sell you more product. What about convergence of the routing system? Those of you carrying full BGP, if one of your links fail, how long does your BGP take to flip over onto the alternative path? Is it completely seamless, such that the users will not even see it? It's the way it should be. Bigger table takes longer for the CPU to handle. BGP updates take longer to deal with. And, you know, Jeff has done the BGP updates, which he runs on his own website. He's been doing that for a few years as well, looking for stability. So again, it's quite interesting to look at. The number one most unstable autonomous system globally is our dear friends at AS9829 yet again. Who would be a customer if the autonomous system was that bouncy? Can't have much internet there, really. To give you an idea, 127,000 updates in 7 days. Well, if you quick at mental arithmetic, 10,000 updates in 7 days is 1 update per minute. So 127,000 is 12.7 per minute, which is about 1 every 4 seconds. That's bouncy. Very, very bouncy. Anyway, we can go through the list. There's Great America Parkway. What do you think? Great America Parkway is in Australia. That seems a bit odd. Ukraine Telecom. I'm going to go through the list there as well. But, anything more than 10,000 updates in 7 days is more than 1 update per minute. That's quite a lot of BGP traffic. So if you carry the full BGP table, 6% almost of the updates that your router sees comes from BSNL, for example. So they're causing 6% of your entire BGP process traffic. Look at the prefixes. /19. Normally people think, oh, it's just a /24. We've got a /19 there as number one most bouncy prefix from Russia. There's a /13. .dz, Algeria. Bouncing a /13. That's a substantial amount of address space that's unstable. We've got /20s, 21s, and so forth. But that's /24. Somebody's obviously got an address block. Given it's a country AU, but Great America Parkway, I know it's in the US, in San Jose. Been along it many times. So I wonder what they're doing. Is it real or something else? Could be one of America's, a 24-hour address space, and then off it goes again. Actually, it can't be because it's 7 years. But, these kind of things are interesting. Anyway, so yes, there's quite a lot of range of operational practices between the registry regions. It's the aggregation, newer providers all over the place. Developing regions does harm affect everybody. It's not that something localized in just one part of the world. It's useful for the whole thing. There's Right 399, that was again a community document produced by the European Internet community, I suppose. There's a Right 399 is the version for V4. There's equivalent version for V6 about what to announce. Basically says you've got an address block from the registry. The expectation is you announce the address block, and you only need to announce some prefixes if you're doing traffic engineering. Nobody can persuade me that more than half of the internet routing table is needed for traffic engineering. People don't have thousands of external links to different providers. And as I was saying at the start, if you think this is just a V4 problem, usually your V6 is just getting almost as bad. Almost half of the announcements in V6 table are from /48, which is the kind of taken accepted as the smallest announcement you can make in the V6 internet. That's all I have. Any questions? Or more like, any commitments from people in the room who are going to go back home and help clean up? If you need help on how routing works, I'm doing a workshop starting on Thursday. Okay, it's V6, but I'll get in trouble for this. V6, as far as routers concerned, is V4 with bigger numbers. Don't throw anything at America. But it is, as far as configuring routers goes. So, if you need help with how routing works, self-advertising. Anyway, half serious though. But yes, seriously though, if any of you can do any help to clean this up. I will mention China Telecom, running ChinaNet, did an amazing amount of work a few years ago to clean up their one. I think we reduced by half what they were announcing. So it is possible. Okay. Nobody wants to ask anything, so thank you very much.
Now we have Vivek Nigam from Ethnic for an ethnic topic. Okay, good afternoon to everyone. My name is Vivek and I look after the member services team at APNIC. Now, as most of you know, APNIC is the regional internet registry for Asia Pacific region. And as an internet registry, there's a lot of data we generate on a daily basis. The data on what IP and AS we have given out, which organizations have received these resources, their contact details, and so on. Now, all of this data is not going to be of much use to anyone unless it is accurate and you can easily access and consume this data for whatever your requirements may be. So on that note, I would like to talk about two topics today. The first one being the WHOIS data quality improvement. So what initiatives APNIC is taking to improve the school's data quality. And then my colleague Juan will show you the new statistics tool to see how you can consume some of this data. So first question, why is the quality of WHOIS data important? What is it important? Well, there are a number of reasons, such as it supports the operation of the internet. So things such as your reverse DNS delegation, routing, geo-IP location, they all use WHOIS data sources. If you're having some kind of networking issues with an IP, or you need to report abuse, again, you use the WHOIS database to find the contact details. And then lastly, but not leastly, it fulfills the goals of addressing policy. So the APNIC resource policy requires our members to keep their registration up to date. So when things change, we need to update their WHOIS registration as well. So the next question I have is, do we need to improve the WHOIS data quality? What do you all think? Do you think the WHOIS data quality is accurate? It's good? Yes? No? Yes? Let's see some hands. Well, if you're a frequent user of WHOIS, you would have noticed there are some issues with the WHOIS data quality. So let's have a look at what they are. So here you can see the invalid contacts that get reported to APNIC on a monthly basis. And we receive almost 100 of these reports every month. And typically these reports say an email address associated with an IP is bouncing or not responding, or the phone number is disconnected. In some cases, the more serious cases, we get contacted by law enforcement agencies and CERTs saying the physical address associated with an IP does not exist. They're running some kind of case and they wanted to go and see the people and they couldn't get all of them. So these are some type of issues people are reporting to us. So once we receive this report, how does APNIC handle these updates? Like, what do we do about it? Well, we have some contact information for all our members we get through the membership application process. And usually that is different from the WHOIS data. So when we receive these reports, we start sending emails to our technical corporate contacts, getting them to update it. That doesn't work, we call them, get them to update it. And generally by this step, most members update the WHOIS, but there are a few cases which don't work. So for those few cases, we log the details and try and find some other ways, proactive ways to update them, such as see if we have some contacts in the organization, or when we come to events like this, like SANOG and other conferences, we see if someone from that member organization is going, we can have a chat with them and get them to update their WHOIS. Now, this is a case study of some of the more interesting WHOIS update cases that we have recently dealt with. So you can see up front is some of the usual steps we take. But once they fail, we took some additional steps, such as try and search for them through Google, through social media, see if there's some additional contacts which did not work. We even went through contacting the upstream to see if they have some contact details they can share with us, so we can get in touch and get them to update their WHOIS. That did not work either. So after all our resources were exhausted, we had to finally issue them a notice of breach of agreement for not updating their WHOIS. And at that stage, some of these members came back, updated their WHOIS. Others did not, so we had to close them and take their resources back. So as you can see, this is a lot of time and resource that everyone is spending 8 to people who are coding it for something quite trivial, like updating an email or phone number. And this is one of the reasons we are taking this huge data quality improvement initiative to reduce these type of incidents. So what are we doing to improve this data quality? Let's have a look at some of them. This is something we did recently. We've improved the who is invalid contact reporting system. So when you search IPs, you will see a little link there to report any invalid contacts. When you do that, it's a simple form. It lets you select what details are invalid, give us some remarks on what is not working, send it to us, and then we use our procedure to follow that up with our members. Now, once it is reported, we need to also make sure that our members can update the WHOIS as easily as possible. Well, if you look at a typical scenario where a person leaves an organization, what are the chances they would fix up the WHOIS and update that before they leave? Probably very unlikely. It's the new guy's headache who comes in, and then this new guy, he has a steep learning curve to understand how WHOIS works, what is a maintainer, what is a person, how to create and update invalid WHOIS. So to simplify this process, we are currently working on some major changes in mind to make this process as easy as possible. And one of these improvements are an option to view all resources for all person objects that are associated with your account. So you can, in one log, you view all the person objects, you can click on them, see which ones are invalid, make them update them. Now, once you have identified some invalid contacts, there will also be a new feature to do a search and replace. So simply specify the new person object, MyPinit will do a bulk update and remove reference of the old invalid ones and replace it with the new one just specified. So these improvements are some we're working now, and most of them should be released in the next month or so. So some of the other initiatives we are doing is the unused WHOIS object cleanup. So a lot of time people create person objects, raw objects, and they never get used up. So they're just sitting and taking up space. So we run a script on the 15th of every month now, with searches for these unreferenced objects which are more than 12 years old, and we simply delete them. Now we do keep a backup, so in case we find the person object missing, you can use a history for it. The RT object campaign, this is something else we've been doing for a while. So it stands for Incident Response Team, and this object was created to improve network abuse contact information. So this policy has been there since 2010, and we have run numerous campaigns to increase the awareness of RT. We send reminders to our members, the ones who did not create them, we pretty much can't tell them and create the RTs, and then want them to verify the RTs are correct. And then after that, we update the remarks attribute in all the parent blocks to say, if you have a network abuse problem, report it to the RT. If it's a technical routing issue, contact the tech C. So it's clear everyone knows where to contact what type of issues. So those are some of the initiatives we've taken. What else are we planning to do this year? One of them is a simple guide we're creating for our members, which will show what each object looks like, how to update them, what's the purpose of them. We're also reviewing the WHOIS database training materials, so our training team will offer a lot of trainings to our members. We'd like them to show our members the new tools, features they have to keep their WHOIS up to date. And then we're also working on the historical WHOIS development. So with the more and more transfers being processed these days, there's more need for members to know previous registration with IP, so who had them before they got them. And even though right now we do have a reverse feature, it has some limitations. So you can only see the history of objects which exist. So once it's been deleted or transferred, you cannot see that history. So these new developments we're working on will cater for those scenarios. And then lastly, we're also working on a WHOIS, or we plan to work on a WHOIS version 4 upgrade. And through this upgrade, we can introduce some new objects such as org ID, and that can be used to clearly distinguish what's the physical location of an organization as compared to the network location. So this can help with geolocation type of issues which the current WHOIS is facing. So if you all have some other suggestions or idea on what else we can try to improve the skills, we'd love to hear from you. And then lastly, what can you do to help improve the service? So if you're a consumer, make sure you report them to us. It's quite easy. And likewise, if you're a member, please do make sure you keep your tools up to date and as well as your internal contacts up to date so we can get in touch with you if you need to get some messages across. And with these initiatives that I have gone through and your help, we hope we can improve the service quality and more importantly, maintain the reserve quality. Okay, so that's all I have. Any questions about the reserve quality? Okay.
Not really um, this is who is.
Yes, so who is good?
443. What do you do in regards to providing some of the lyrics or any tips on some of this environment and the Western interest?
I'm not sure if I got that question right, but are you referring to the policy proposal?
No, this is not policy, this is purely on technical thing, as opposed to, providing who is data on the Western interest versus who is what that way the data is machine readable, can work with
Yeah, so we have implemented RDAC.
okay. All right. Then that's that. Then I'm done with my question. Thank you.
Okay. There's one more question?
Hi, you mentioned an interesting thing that when you are not able to validate who is you try to contact the operators. My question is, assuming that a really extreme case happens that you are not able to contact and you really go for the breach of agreement, do you really monitor those resources beyond that point? I'm asking this because recently I noticed that there are almost 486 ASMs available. These belong to all RIRs who don't have any valid record at all. I mean, these are ASMs without any registration to any of the RIRs.
Mm-hmm. Okay, it's a good question. So I think if I understand the question correctly, in the event there's a breach and we take the resources back, we delete the host registration. And that's why if someone doesn't look up, they can see it's not being delegated to anyone. And in the event those people are still out in there and announcing the resources, then we have a separate procedure that our registration service can use to follow up with their upstream, getting them to stop announcing it. Because we understand until it stops, you can't put it back to a free pool and we will get in the future.
So how that works? Does it work in a reactive manner that ASM is visible and someone tells you and then the reactive team works, or you automatically contact the upstreams when you deregister?
We check it ourselves proactively. So once we reclaim the resource as a part of a procedure, we check that it's not being announced anymore. And if it is, we have a procedure to follow it up to get them to stop announcing. Okay. Very good. That's all the questions. I'll now pass it on to Tuon, who will explain the new statistics tool that we're planning to provide to help you consume some of this use.
Hi everyone, my name is Juan. I work in the registration services at APNet. I've done this demo live yesterday afternoon, and we received some good feedback. So if you have any further feedback about the presentation, we'd like to hear it. So first, to start off, has anyone used O3 before? So pretty much, it's our old stats program that's been there for at least over 10 years now. That's what it looks like for everyone who hasn't seen it. It's done a very good job. Pretty much you can select different views, different types of graphs, and there's lots of different selections you can make. But we're currently finalizing a new stats tool, so I'll give you a demo of it. The internet's not too great today, so I've actually just done screenshots for today. But to start off, this is the FTP step. So as a RAR, we generate a lot of data every time we make a delegation. So whether that be AS, V4, or V6. So every time we make a delegation, there's a log. And this is pretty much what the log looks like. Pretty much all the log is saying is Apex delegated to this economy, this resource, this prefix or the starting prefix in the length, so how big it is, and whether or not it was an allocation or an assignment. But to make this more usable and a lot easier to read, we've done something similar to O3, so put it all into a graph for you. Just be aware this isn't from APIC Lab, so it's not an APIC Lab project. We've sourced it out to something called Elephant. And we're currently talking our infrastructure service team at APIC are getting the gear ready to start hosting this. So with the demo, so this is all offline. When you the first summary page, you can view all the resources that APIC has delegated. So the bottom graph is in total, everything that APIC has given out. So you can't read that from the back, but it's AS, V4, and V6. And the top two three graphs show the same thing, but they've split it up over the years. And each color in the graph, it represents a sub-region. If you log onto your mobile device or tablet, or if you have a lower resolution laptop, you'd actually readjust the graph, and it's quite responsive. So I'll just go over some of the features that we've put into it. First one, if you roll your mouse cursor over, it shows the value. You can see those three dots on the right. When you click that, it scrolls over the legend. So the reason we went for that option was we initially had the legend down the bottom, but then it took up quite a bit of real estate for the graphs. With the selections, so each type of resources, there's different types of selection. For AS, you can have total AS. You can split to 2 byte only, 4 byte only, and cumulative. So all the graphs have a cumulative option. So that's the one for AS that you're just seeing on the top. The next two are the V4 and the V6. With the V4, it's over the last couple of days, it's just changed. So it's now, it's a total, so it's in /32, 24 is total number of delegations. And with the V6, it's /32, 48, the number of delegations. So another feature is the ability to save the graph. So we've gone for PDF, PNG, SVG, JSON, and CSV. And just so you can see what actually the file looks like. So with the CSV, we've also added a color code if you want to copy the color. So instead of the summary page, you can drill into each specific resource if you want to view ASN only, or for V4, and then V6 only. And you can also drill down per sub-region. So if I wanted to look at South Asia, and then down again to Nepal, so Nepal. Another view is an organization view. So if you click on the little red, where that little red arrow is, it shows who the resources are being delegated to, and what resources and their allocation date. When you click on any of them, so if you click on any of those ones, we'll grab some data from WhatsApp. So we're stealing the geolocation data that we're getting off Maxon. Another view is a map view. Pretty much all the darker colors represent that there's more resources delegated to that economy. So last time we had some feedback that you could add additional population data, so you can view by resource per head. So if I wanted to drill back from here, you can go back to South Asia and then back to Asia Pacific. And later on, we're planning on embedding some of these graphs on the APNIC website just to replace some of the existing graphs. If you have any feedback on what you've seen today, Vivek and I will be here over the next few days, and we'll try to be at that desk outside where the APNIC banner is during the breaks. I'll just finish off with the next APNIC meeting. So this next month we've got our APNIC meeting in Auckland. You're all welcome to come. But we do understand it might be a bit far from home. So the following meeting after that will be APNIC 42, and that will be held at Dhaka in September. And I just want anyone that hasn't created their roles yet, Vivek and I will be here the next few days. We have some nice t-shirts in extra large, if it fits. Apart from that, another thing I just want to quickly say, after a few discussions with a few members around the place over the last couple of days, we've heard there's a couple of hot topics with big IPv4 shortage. So come talk to myself or Vivek over the next few days. Are there any questions?
Do you have any questions for him? No, good to go. Thank you. All right, we have Samit Chana to brief us about the internet backbone infrastructure report. Look to that in brief.
So, my name is Samit and I work for the schools in Nepal, which is very down on the bottom of the slopes and creating the report. So basically I'm going to talk about a sort of brief work about internet backbone infrastructure of Nepal. And I'm not going to take much time because I know the party is waiting first and also years in this. So there you go with some brief history. Nepal established the first telephone exchange in Nepal in 1940. The first international connectivity happened in 1940. Basically, this is all copied from Google, so I haven't tried that yet. So in 1940, the Nepal Telecom established the open wire telephone connectivity, which is also known as Akashvani in India. That is between Kathmandu and India by also. So it's a open wire connection means it is a physical wire that is pulled between the two bodies between two countries to have a connectivity. Then in 1964, that's a review between India and Pakistan was established that started by International Telecom Corporation. Then finally in 1982, we have a satellite earth station, and basically that it opened the door for other providers to connect with the internet through satellite, right? So basically you can see that in 1994, basically a company named Mercantile Office System, which is now also known as Mercantile Communication, is also supporting as here. So they started commercial internet and email service back in 1994. I heard that some non-profit organizations like Ronas also started some kind of services on 1993, but I cannot verify that yet. So finally in 1995, two other service providers also started the same services along with the internet, but using a 64 kbps network. Continue with that, then finally in 1996, the process of establishing a VSAT, very small application terminal, right? It is a small version of satellite Earth station big satellite. So that allowed operators to bypass the telecom and connect directly to the internet to all around the world, right? So in 1997, the first optical backbone was connected in the place in Nepal called Leaders, which is on the border, and on the India side is Roxor. It was established by Nepal Telecom with DOT in India. I don't know what the DOT is doing with this connectivity because there is no internet at all. Right? But maybe it's for signaling or some for traffic, I don't know. Then finally, after 6 years, private operators started the internet. Finally, Nepal Telecom started the internet service in 2000. So they are pretty late. Then, luckily, Nepal Telecom started established first internet backbone using optical fiber in 2007. That happened from a border place name called Bhairava and SANOG in India by Nepal Telecom. And actually, it's created a new evolution in the internet industry. Right? So it started exponential growth of internet traffic in Nepal. Then finally, after 1 year, private ISP were still on visa to manage for 1 year. Then luckily they also happened to connect the first cross-border connectivity with India in 2000. So basically it was started by two companies, it's Worlding, my company, and one that communication. They both joined together as a consortium and they established the first connectivity. It had to open the door for all the private operators to provide high security. Then in 2011, the Nepal Telecom also interconnected with China Telecom to speak that, but that was never been used for internet. Then in 2012, again private ISP started connected second cross-border with India that added the dependency and reliability in internet. So this is how the connectivity in Kathmandu looks like right now at present. So I start with this venue, right? So here we are in Yakanati, right? So these all purple dots are ISPs, random ISPs that are just dots. So we are connected with the two fiber from Yakanati to two different ISPs. Then all the ISPs actually eventually goes to a place called Kutatar. This is a Nepal Electric Authority road distribution center where all the ISPs in Indian telcos they aggregate the connectivity. This is one more major point of failure. We are very lucky enough that in the last year also no such infrastructure infrastructure was damaged at that place. And even though it could have been bad, sorry, it could have been worse, it was only bad, so we were able to recover only 8 years because no major infrastructure damage happened at that time, right? So we are very fortunate for that at that time. So all the ISPs they got connected in this place for many years in Kutatar. And from that place, we have a two fibers that one goes to Bhairava, border with Nepal, and another goes to Pekora towards Nepal. So we have a few fibers going there. There is another fiber also that goes to the highway, it's overhead cable, but that is not being used to carry the major internet traffic. So now going to cross-border points, we have several cross-border points in Nepal. So you can see that on the southern part we have India with a lot of cross-border points, but there are only a few on the China side, on the north side. Obviously, it's because of the trading is very because it goes over the Himalayas. Right? But to cover Indian connectivity, there are only three major points. One is Bhairava, and one is Regions, and right on the east is Gujarat. So there are only three interconnection points from where the traffic get exchanged via India. So now talking about backbone, right? So as I said in my earlier slide that from Kathmandu we have two fibers that goes towards the border, right? One that goes towards place called Bhutwal and to Bhairava, where we would connect with Airtel, Tata, and I recently heard that some were also connected with Vodafone. It's good because the competition is increasing. Hopefully our bandwidth rate will go down. Right? And we have similarly another fiber that goes from Kathmandu to Pekora, then say towards Singapore. So we have a pretty much very robust link because this is a fiber that runs over the high voltage NA power grid. Right? So and fiber is of course OPGW and combination of ABS cable. So it's pretty much very reliable. So that very minimal outage. Back in 2008 and 2009, we were major outage once because the ADSS fiber that was below the streets, below the highway, and one of the bus unfortunately plunged into the river and it broke the fiber. And another big incident is I think if I'm not wrong, is 2009 when the lightning hit the OPGW fiber and it melted a lot of code. And there was an outage of almost 3-4 hours. But now we have a backup OPGW fiber, so now I can say that last year we have 100% uptime for this whole segment. From the same link, we have another link that connects to another cross-border event, and we have a one person, we have a ADA OPGW and ADSS fiber, and another link we have a one-to-one fiber. And in this cross-border, we have a connectivity with Airtel and Tata. And from the same link segment, one fiber extends towards buildings, right, towards the east, and there is both this segment does not carry much traffic, but still there is a connection with Airtel, Tata, and BSNL. BSNL, I think the interconnection will be only for private telecom, and it's not carrying that much traffic. So there is a redundancy plan from Kathmandu from other side of the town, and this is a project named SASIC. We have been hearing a lot about this project since God knows how many years, but it's never been executed and it's never been built. So there is only a box, but no action. Similarly, on the northern side, as I said earlier, we have an interconnection with SANOG Telecom. This is built by Nepal Telecom, but that fiber is almost unusable now. And during last October, most of the segment has been done, so it has to be now rebuilt. There is also another cross-border connectivity with China plan that is its place name is called Raswagari, and some of the private operators are trying to build that fiber along with this segment. But this segment is very challenging, and as you know, it goes towards the Himalayas. It's very cold. It's very prone to the landslides. So building a network is not a big deal, but maintaining the network could be a very it's not a very humongous job. So going further, so from Nepal, of course, all the fiber it goes towards India, and it goes over the backbone of Tata and Airtel, even Airtel. So they have a lot of redundancy here, and they also have a so-called base on network going out there. But most of the cable from Nepal it goes to either from Mumbai exit or to Chennai exit. So if the provider is taking a traffic from Tata, so generally they look for Mumbai exit, and if they are taking from Airtel, then they generally take for Chennai exit. From Chennai and Mumbai, of course, there are undersea cables, and it will go all over the world. So IP transit points. So basically, I just discussed about the physical cables. Now, I would like to talk about more about IP transit points. So all the operators, typically, they have their own preferred choice to get IP transit point. So a lot of the operators, they mostly get their traffic from either Mumbai or Chennai. If it is Tata, it's Mumbai. If it is Airtel, then it's Chennai. But some of the providers also go beyond Singapore. Then some goes to Hong Kong, some goes to London, and some fancy ISP also goes to New York. I don't know why. Alright, so this is how the upstream looks like. Right, so we have all the ISPs connected on the IX. So basically, the connectivity between all the ISPs over IPX is pretty fast. This is under 1 or 2 millisecond maximum. Then we have an NSP there, which connects to the IP transit providers. So of course, there are a lot of ISPs who are also NSP. Right? So those who prefer the Hong Kong IP transit, they have an IP transit from PCW. Those who are doing from Singapore, they have upstream as entity or CTL. From Chennai and Mumbai, of course, it's Tata and Airtel. And some of them who are going to London, they have a Fusion, India Solena entity. And of course, some of them, we are also connected with Delhi, Gold. So that's how the connectivity looks like. And I have also put on the latencies, right? So from Kathmandu, if it goes to Hong Kong, it's roughly around 130 milliseconds. And if it goes to Singapore, 95 milliseconds, sometimes 100. In Chennai, 45, Mumbai, almost similar. London will be high, 165. Then Delhi is 25 minutes. So present IP capacity. So we have seen exponential growth in paid IP transit. Of course, our time level was very happy. Right? So approximate now today we have a aggregated total close to 50 Gbps of peak IP traffic. The backbone is okay, pretty much. It can cater up to 50 to 90 G of traffic. The Google cache traffic is also pretty impressive. We have approximately 45 to 50 Gbps of peak traffic. Serial traffic is also pretty good, 8 to 10 Gbps. It's basically atomized traffic, right? But the sad part is we only have 1 Gbps internet traffic over in the apps, right? That is because we don't have much local content there. Whoever has a content they prefer to post outside Nepal, either it's Amazon, GoDaddy, Cloudflare now. If they don't have a data center in Nepal, so maybe all the content that will be posted. So that's why we see that there is a difference of 1 to 100 now if you calculate all the traffic. So this is the fact part. But since last couple of years, there are a lot of data centers and the cloud service providers are coming in. So hopefully that will change in the coming years. So the local content owners and the host hopefully hosts everything inside Kathmandu in our own data center, or hopefully the CDN providers like Cloudflare or Amazon GoDaddy, some of their data center or gas box in the product. All right, so what next? So capacity is never enough for us, right? So it is too phenomenal for everyone. Right? So we used to see a bandwidth growth of 50% 10 years back. Now today we see a bandwidth growth of almost doubling in 12 months. 3 years back it used to be 18 months, right? So you never know. We may see the growth of double 100% growth in the next 6 months, right? So capacity building is very challenging and tough. We have to upgrade, and upgrade all the time. So how long we can upgrade? So we are not able to plan for even for 1 year, right? So how we going to plan for 5 years? Right? So how will it's going to go? So we are clueless. So what we can do? We basically all government, we just community, right? So that's all I have to say today. Thank you very much. Yeah, questions.
Any questions for Samit? No.
Thank you. Thank you very much.
The next and the final rounds of presentations are for the regional nodes and the IX updates. Maybe one by one we could start giving up the IX updates. Bhutan, Bangladesh, anybody from Bangladesh? Maybe, giving up. And maybe Bhutan and Nepal. Anywhere else? Please talk to me if anybody wants to present their IX updates or would like to talk about peering or I don't know, some updates, I don't know. Do we have anyone from Bhutan? Or even present? Somebody even present? Yes.
Sorry for the technical glitch. My name is Simon. I am the executive committee member from BIGNOG, it's Bangladesh Network Operator Group. You can say the younger brother of SANOG. So my first thing is that why we need BIGNOG. So and why not SANOG? Why not SANOG works like is enough for us? Is it? So I just got information from the local host. 167 people registered for the workshop, but we can accommodate only 120. Oh, sorry, 90. So 167 and 90. So that is why. So you can now understand that why we need SANOG in Nepal, and why we need a kind of like local logging also in Nepal. Talking about Bangladesh, we are now consuming almost like this month, we are touching 200 Gbps of internet. We are connected terrestrially to India, and we have our own submarine cable. So 200 Gbps of traffic we are handling. So where we can find engineers. So that is why we need NODs, and that is why we need to share this technical knowledge with our community. So maybe when we started BIGNOG, it's a forum of the people from every sector. I should say like telcos, ISPs, from I should say educational sector also. We have so many people. But what are the objectives? Mainly, with the objectives are that we want to work together to build a better internet in Bangladesh. That is our main motto to start building on. And also, the thing is that yes, in let's say in a Juniper training or in a Cisco CCI, you can get some information that is written in the book, but operational experience, that is only you can get this kind of knowledge. We say next 5 days what Philip, what Papu, what Champika will tell us in the workshops. That is the real operational experience, what they get from their life, that will be shared. And that is one of the most important part of the knowledge. So, as we've seen that SANOG comes after every 4 years to Bangladesh, we have to do something. We have to do something to make it every year. So that is why BIGNOG is there. And then another thing is that we have some small research every time we going on in our country. So we want to conduct those operational research activity. And also we have the problem is that if anybody comes with a small research proposal, they don't have that kind of facility. But in operator sector, let's say in our operation center, we have so many big routers. ASR, some have 9K, some have ASR 1K, some have Juniper MX 480. So we have so many facilities to accommodate those kind of research proposal. So that is why NOG is very much important. And lastly, I should say that we have to promote our local talent. From Bangladesh, there are so many people who are now working outside. I should say in Ethnic, I should name like let's say Google, I should say Akamai. There are so many people are work outside. So that is why to build up the local community, the local law has a too much footstep. So from BIGNOG, we started with a very small footstep. The first one, we started with a small website, and then with a small mailing list. But that small mailing list didn't like presently we have 800 members in the mailing list. So if anybody has a problem, I think Philip is also in the mailing list. From NSRC, Brian is in the mailing list. So many people is in the mailing list. So from not in Bangladesh, any problem generated in Bangladesh that is solved by not from Bangladesh, also from outside of the world. So with that, so SANOG is last SANOG came to Bangladesh in 2013. So we are waiting for SANOG, and then we did our first BIGNOG. And the first BIGNOG, the participant was like 180 plus. We have three texts for our workshop, and on this workshop, I think MPLS was there. So routing, network security, and cloud was there. So we got support from Ethnic, we got support from NSRC to do those workshops. This is one of the green picture from BIGNOG 1, and luckily we have a regional meeting with BIGNOG 1. This is another, our two of the ministers who are very much encouraged to join this kind of events. And I should thank to Paul. Paul was also in that meeting. I'm seeing Brian. Then we had BDNOG 1. So Bangladesh is a very small country, but still all the technology is like concentrated in capital. So Dhaka is our capital. But what we try to do, we want to do two NOG programs, events in a year. One in Dhaka, and second one is outside of Dhaka, any place outside of Dhaka, where we can get some very small amount of support from the local good hotels or like good conference centers. So the second conference we did in Coxbazar, and we did it Coxbazar because our only single submarine cable, CVME4, is landed at Coxbazar. So that is why we did it Coxbazar, and the participation was 90 plus, and we have 2 workshops there, 2 tracks. So these are the number of participants, like how many participants came from this, mainly we get so many participants from ISPs, and also we get participants from the education sector and also from government. See some of the links from the papers and our conference. These are the workshop participants of BDOT2. Some of the pictures from the BDOT2 conference. Then we had BDOT3. Then we again came back to BDOT3. And on BDOT3 we had 200 plus participants, and we had 3 workshops. So again, in Dhaka we get so many facilities, so that's why we can do workshop in a big way. This is the yes. This is on BDOT3 we get people from ICANN. We get this is Donald from Google. And this is one of the participants. So on average, we found that 50% of the people in our conferences, they came from ISPs, 70% they came from telcos, 12% they came from banks, 5% they came from NGOs or education sector, and 3% mainly they came from enterprises. This is one of the BDOT3 conference and BDOT3 workshop participants. Now then we have BDOT. So we have BDOT4. Again, BDOT4 is outside of Dhaka. It is in Select division. The district is Srimangal. So we have like 50 plus participants, and the workshop is two tracks of workshop. Mainly we did cloud MPLS deployment and cloud computing. So this is the BDOT4 workshop participants. It is also the place called Srimangal. Then we are having BDOT5. Again, we are coming back to Dhaka, and most probably we will do BDOT5 with ION. I think everybody have heard about ION. So we are doing it 7th April on this 2016. Then after BDOT5, we have already scheduled BDOT6. I think Tuan already told you that we are doing BDOT6 along with Ethnic 42. So that will be 29th to 6th October. And also we are trying to encourage like fellowship, but mainly the fellowship is we are giving out in locally. But if anybody wants from outside to join any BDNOG program, we are also hoping that from Nepal we want to get a big gathering in Ethnic 42 and BDNOG 6. So I am welcoming you. If you want to contact us, we are open on Facebook, Twitter, and YouTube. So you can contact us immediately. And from BDNOG, myself, Pappu and Moin, we will be here until like 2nd February. If you want to know anything else to do, we're happy to invite. Thank you.
Do you have any questions, friend? No. Okay, we have a gentleman from India who's going to speak about new IX. Mumbai IX? Mumbai CIX.
Namaste everyone. I'm Vidin from Mumbai Convergence Hub. We don't call ourselves an internet exchange because Nixie is the only internet exchange in India. So we are a Convergence Hub, a peering hub, established in August 2014, operational since a year now, open, career neutral. Anyone with an AS number can join us, no regional restriction, no policy restrictions. We call ourselves like we are the fastest ways to connect to India and fetch the content. We probably have a lot of customers by now. Telcos, we have Airtel, or Lines, Geo, Idea, etc. Content, we have Akamai, Google, Language, one, etc. Along with that, we are also running a small initiative called Internet First. So this is something that we would love to promote. So what we identified that the problems of the internet is common for this part of the country. We, India, world's second largest country when it comes to internet population, but problem for everyone is the same. So we are trying to solve one by one by one. So in that, just one of them is Mumbai Convergence Hub. Probably in the coming days, you'll be able to find more details in internetfirst.in website. And in case if you have any queries, you can catch me. Thank you.
So can you list down your members or the traffic?
We at the moment doesn't share the list. Probably we'll be able to see that probably in a month's time. I mean, this is a long-term because that has been happening, but since we always wanted Nixie to enjoy the benefits, so we really wanted to go and spend a lot of trouble, so we kind of keep it secret. We have over 640 Gbps of subscribed ports, but hardly 120 customers right now. In that connected one will be less than like 40 of them.
Thanks. Right, we have Shirin Mother, which will be this on the ground now or the ground now.
Hello again, Norbu here. I represent at this time BTNO, which stands for Bhutan. So it was founded in 2014, and the first meeting that we had was November 2014. And the gentleman here sitting, Mr. Philip, has been very instrumental in providing the guidance and support in setting up the BTNO. And also, we also thank the support of NSRC, APNIC, ICAM, ISO, Google, and all the regular support and the sponsorship committee. So last year was our second NOC. The objective of the setup, the NOC setup is pretty similar to what Simon from BTNOC explained earlier. So they are the younger brother to SANOG, but we are the smallest brother to SANOG. So I think we are so small, so we now remain the smallest. So last year, during the first event in November 2014, we have had around 85 participants, and we ran, the format was also again pretty much similar to what BTNO runs. So 4 days of workshop followed by 1 day of conference. And in the first one, the November 2014, we ran 3 workshop tracks, pretty much similar to again what SANOG usually do. So those were virtualization and cloud one, and the routing, the third one was security. Last year, so we hosted in September 2015, and we ran 2 tracks, routing and the security. So this year, so like we Bhutanese are so late that we keep everything to the end. So we hope to, we haven't announced the dates yet, but then sometime towards probably the third quarter of this year. Our initial plan was to host 2 events BTNO in a year, but then we could never make 2 in a year so far. So hopefully in the future. So we also run a mailing list and our website, or we also have a website, nog.bt, and then we are reachable there. Thank you.
Okay, lastly, we've got the Nepali Internet seems to be just some of the response. Yes.
Good evening. I'm Indigo Gudal. I'm from UPI. So, we are open IS, this is states. We will open this is a beginning, anyone can AS number, the one ID system IR, open to join our exchange. Started service in 2002 with 4 members, 1 location and 1 switch. So today we have 2 locations, we have 4 switches and 22 plus 4 satellite, altogether 28 members. So we added only about 4 members in 2015, but we got 1 more members in the year. So we also received across anchor last year. International traffic is just like Soviet days, around 50 CBs, and domestic traffic is also quite similar. But most of the domestic traffic is CBS, and only about 1 CBs of peak traffic is flowing through NKX public ports. So traffic growth, it generally needs to double every 12 months. So we have been doing this for a while. This time I notice it's growing slower than usual. So it could be related to last week or actually the development and use power outages. So the growth is not slow. Last month in the month, I think now it's safe to say fiber is still growing. All the major providers are doing fiber. Some irrigation is also big, but only Nepal Central is doing that. So in the rural and suburbs, it's wireless. Some PLG were doing cable last month, and I think there's still cable-based metro solutions. We have been doing IPv6 since 2015, but the number of default peers, V6 peers are not growing that fast. And actually it hasn't grown in the last few years. So I think the thing that's lacking is still, it's very difficult to get a V6, native V6 connectivity as an end user. So in the future, we're expecting more members. Enterprise are interested to join Netflix now. So we could bring us more members there. And we're planning to do in talks with as well as some demand from members also. So this thing will happen full for it. And we're planning to do more training events. Apart from SANOG and others, we're planning to do more events in the coming months. Thank you.
Any questions for you? No. All right, well, it's been all right. It's good for me. It's good. Huh? No, I don't know. Anybody would like to speak? Actually, nobody has a question, so. Anybody would like to speak?
Hi, Samit again. There were a lot of questions going on since after months that why there is no norm in Nepal also. So what I would like to comment announce is in the next couple of months we are also probably inaugurating operator groups in Nepal. So there is a debate also going on about how to get what to name it. Some say someone is suggesting NP norm, someone is suggesting norm, someone is suggesting net norm, someone is suggesting Nepal norm, right? But we already have an actual Facebook created as a NP norm. So once it is already inaugurated, then we'll say more. Thank you.
All right, any more? Anyone would like to speak? Okay, we got training personnel PCS from, sorry, DBA from PCA. Anyone else would like to speak?
Hi, this is Divya from PCL. So we are AS42, AS2856, and here we propose sharing policy, and in South Asia we are doing that BDIX, NPIX, and so please write an email to sharing@pcs.net for us. 250 appeals are. Thank you.
All right, we have a social event this evening at 6:30. Meeting pushed out from here to the garden opposite the hotel, back of the hotel actually. The name is the Crystal Ball Room, I guess. But then it's the garden.
You go down and
Turn right, turn right.
turn right.
Turn right.
Right.
Right, go down and
So I was told that it's raining, but they have to
all right. If it rains, we're gonna have it at the chimney restaurant. Anyway, so we'll follow because there'll be a lot of people to be there to help you. Make sure you have your cards with you for the dinner program. Thanks.